Assalamualaikum greetings. In this video, we're going to take a look at the nomenclature of benzene. Normally, benzene can be drawn using this two calculus structure. The first one is a 6-membered carbon ring, and then we're going to draw a conjugated double bond inside the ring. The other structure that we can use, if we change the position of the double bond, it can also be located at different location, as long as it is a conjugated double bond. So this is what we call as the calculus structure. In order to simplify the structure, we can combine both of these structure, and then we can draw the resonance structure by drawing a 6-membered carbon ring with a circle inside. Please draw the circle inside the benzene ring proportionally to the size of the ring. Try to avoid to draw the structure like this, where you just draw a small circle inside it, or worse, you might draw the circle outside the ring. Right, this too is considered as incorrect. Other than that, you should be able to familiarize yourself with the other convention naming for the benzene compound by using the ortho, meta, and also the para system. Let's take a look at some of the questions related to the nomenclature of benzene from the previous examination papers. The first question was taken from CHM 257 papers. You can also refer to this paper instead of CHM 258 code because they have similar questions. So as you can see here, for the past few years, the question which directly asks for the IUPAC name or the structure is quite uncommon. So basically, most of the question will straight go into the synthesis questions. For instance, for this one, the question is predict the synthetic pathway to produce following compounds. So basically, this question would like to look at the synthetic sequences, right? However, it is important for you guys to identify what are the compounds of the derivative of the benzene derivative that we are looking for. So in order to answer this question, first and foremost, you should be able to draw the product that is requested by the questions. Alright, first one is orthonitrobenzoic acid. Let me remind again that any attempt to name the organic compound must be based on these two guidelines. The first one is the functional group. Second one is the longest chain. Same goes with the benzene. We're going to identify first the parent, and then we're going to take care of the substituent attached to it. Alright, for the first one, A, orthonitrobenzoic acid. Of course, we're going to try to draw the benzoic acid first. So what is benzoic acid? Benzoic acid is a common name after a benzene which attached to the COOH group. So automatically, COOH will attach to the first carbon of the benzene, and then we can simply draw this number the rest until 6 carbon for the benzene ring. So settle for the benzoic acid. Other name for benzoic acid, it can also be called as benzene carboxylic acid. However, based on the common name, we're not going to use the benzene carboxylic acid. We're going to use benzoic acid instead. Next, we need to draw the substituent of nitro. We know that nitro is NO2, but it is positioned at O, which means ortho, which is positioned at 1,2 or 1,6. So if we already assigned carboxylic acid position at carbon number 2, the nitro should position between carbon number 6 or carbon number 2. So the structure will be looking like this. Remember guys, the ortho, meta, or the para configuration can be only used towards the di-substituted benzene, which means there is two substituent which is located to the benzene ring. If it contains more than two, we cannot use this naming convention. We need to use normal numbering. Alright, this is for A. Okay, what about B? For B is, the base structure will be benzene sulfonic acid. So how do we draw the benzene sulfonic acid? Benzene sulfonic acid is referring to the structure of benzene which attached to the SO3H structure. So this is the benzene sulfonic acid, and automatically the sulfonic acid will be positioned at the first carbon of the benzene, and we can number the other carbon inside the ring until 6 carbon. So this is the benzene sulfonic acid. And then we have attachment of substituent of chloro. Chloro is Cl, which is positioned at the meta configuration. So if it is located at the meta configuration, meaning that it is positioned at 1, 3 and also 1, 5. So for this structure, it's stated as M. We're going to remove the H from carbon number 3 and then we replace it with Cl. So there you have it, M-chlorobenzene sulfonic acid or meta-chlorobenzene sulfonic acid, because the position of substituent is located between carbon number 1 and also carbon number 3. That's why this will be considered as meta. Moving on to the next questions. Again, this question was taken from CHM 257 for paper June 2018, part A, question number 10. Same like the previous question, as you can see here, this question is focusing on the synthetic sequences of the benzene compound. Again, you should know that in order to answer this question, you should be able to draw correctly the structure that is requested by the questions. So let's take a look at A first. For A, again, the parent name is benzoic acid. So we might as well draw the parent chain first, which comprises of the benzene with one of the carbon attached to the COH. So automatically, carbon which attached to the COH will be positioned at the first carbon, and whether you are going to for clockwise or anti-clockwise numbering, make sure the number of carbon benzene ring should be 6. And then we can see that we have a substituent position at ortho, meaning that it must be positioned between 1, 2 position or 1, 6. This is for the ortho configuration. Now the structure which attached to the ortho configuration will be third butyl. Third butyl is consists of 4 carbon, and then it should be written like this. Right, this is the first carbon, the second carbon, the third carbon, and also the fourth carbon. So for this time around, I'm going to put the third butyl position at carbon number 6. We can also put the carbon at carbon number 2, so that it become ortho third butyl benzoic acid. Okay, this is for A. What about B? Benzyl bromide. Okay, this is quite special. If we draw the bromide first, it will be represented by Br. Now, how do we draw the benzene structure? The benzene structure is referring to a benzene which attached to the carbon first before it attached to the bromine. The structure of the benzene, again, is referring to the benzene structure which attached to the carbon, and this will be called as benzyl. Just like the carboxylic acid just now, we have a benzene which attached to the COH. So the structure here is what we call as the benz. Please take note. The C here does not have sufficient number of hydrogen, therefore don't forget to put H2 at it, so it will become complete. So this is the structure of benzyl bromide. In this case, the benzene compound is acting as a substituent, while the bromine will become the base compound or the parent compound. Okay, there you have it, the two structure of ortho third butyl benzoic acid and also benzyl bromide. And finally, moving on to the last question, section 257, December 2018, part A, question number 10. First and foremost, we need to draw the para-nitroaniline. The para is referring to the position of the substituent at carbon 14. So again, we're going to draw the aniline structure first because it is the parent. Aniline is a benzene compound and one of the hydrogen is being replaced with NH2. So this structure will be called as aniline. Again, the first carbon will belong to the attachment to the substituent, and then you can just number the ring according to your preferences. It can be clockwise or anti-clockwise. As you can see here, we have P, nitro. Nitro is NO2 structure, which is located at position 14. Since position 1 has been occupied by NH2, it left us with 4 only to draw NO2 attached to it. So we have this para-nitroaniline. The last structure, M-ethyl nitrobenzene. So in this case, we have a nitrobenzene structure without any special name to it. For nitrobenzene, it's the structure of benzene which attached to the NO2, and then we have the convention of meta, which means that it's positioned between carbon number 1 and also carbon number 3 or carbon number 5. Therefore, for this example, I'm going to use number 5. I'm going to replace the hydrogen located at carbon number 5. I'm going to replace the hydrogen from carbon number 5 into the ethyl. Ethyl is being represented with a 2-carbon chain. Right, this is carbon number 1 and carbon number 2. And there you have it. This is the meta-ethyl nitrobenzene. Please take note that sometimes the benzene will be treated as a substituent. This is also based from the guideline of functional group and longest chain. For instance, if we have 9 longest carbon chain and then we have a benzene attached to this parent chain, so instead of making the benzene as a parent compound, we're going to treat the linear structure as a parent compound. So as you can see here, in both numbering, the benzene will be positioned at carbon number 5. So for the longest chain, we have 9 carbon. For benzene, we only have 6 carbon. Therefore, the aliphatic chain will become the parent chain. The benzene will become the substituent. So first we're going to name the parent chain. So 9 carbon with 3 chain will become nonene, and there is substituent located at carbon number 5. For the benzene, it is not benzene. It's supposed to be phenyl. So the answer will be 5 phenyl nonene. Remember, we cannot simply take the carbon from the parent chain because this belongs to the aliphatic structure. So you cannot name it as a benzene. Benzene need to be separated from the main chain. So this will be the answer, 5-phenyl nonene. Try to answer the other tutorial question, and we're going to discuss it in the Telegram group. See you guys in another video. Goodbye.